special right triangles.
Let us have a little recall about right triangles. A right triangle is a triangle with one right angle. The side opposite the right angle is called the hypotenuse, while the other two sides are called legs. The total sum of the angles of the triangle is 180 degrees, and the right angle is 90 degrees, so the other two must have the sum of 90 degrees. Moving on to special right triangles, there are two types. First is the 45 degrees, 90 degrees, which is called isosceles right triangle. The second is the 30 degrees, 60 degrees, 90 degrees triangle. Let's first discuss about the isosceles right triangle, which is defined as a right triangle with a congruent two legs. An isosceles right triangle therefore has angles of 45 degrees, and 90 degrees. With only one given side, we can solve for the rest of the leg by using the pattern formula. In the pattern formula, we have to take note that H is hypotenuse and L is leg. We can solve for the hypotenuse or the longest side by multiplying square root of 2 to the measure of the leg. We can also solve for the leg, and that is by taking half of the hypotenuse and multiplying it by square root of 2. Example: given a 45 degrees, 90 degrees triangle with one of the legs measuring 7, we can solve for the hypotenuse. H is equal to L square root of 2. Substituting the leg with 7, we arrive at the answer x is equal to 7 square root of 2. Note that since a 45 degrees, 90 degrees triangle is an example of isosceles triangle and the given 7 is one of the legs, then automatically the other is also 7. We can also try the Pythagorean theorem solution. Since we need to find the hypotenuse, we are going to use the formula for hypotenuse, which is c squared is equal to a squared plus b squared. X squared is equal to 7 squared plus 7 squared. X squared is equal to 49 plus 49. X squared is equal to 98. X is equal to square root of 98. X is equal to square root of 49 multiplied by square root of 2. X is equal to 7 square root of 2 for the final answer. And that's in for the 45 degrees, 90 degrees isosceles right triangle. Now, let's have the 30 degrees, 60 degrees, 90 degrees triangles. And by definition, if you draw an altitude in an equilateral triangle, you will form two congruent 30 degrees, 60 degrees, 90 degrees triangle. You can refer on the picture on the right side for this. For the 30 degrees, 60 degrees, 90 degrees triangle pattern formulas, we should start on knowing the parts and relationship of these parts. A 30 degrees, 60 degrees, 90 degrees triangle has a shorter leg, a longer leg, and hypotenuse. The hypotenuse is 2 times the shorter leg, denoted by 2a is equal to hypotenuse. The longer leg across from 60 degrees is equal to the shorter leg times square root of 3, denoted by A square root of 3 is equal to longer leg. Lastly, the shorter leg is denoted by A. The short leg is half of hypotenuse and vice versa. The hypotenuse is twice the short leg. The longer leg is equal to the product of the short leg and square root of 3. Using the patterns to find the length of side, x is the short leg, so A is equal to x. 2a is equal to hypotenuse. Hypotenuse is equal to 14. By substitution, 2x is equal to 14. X is equal to 1 all over 2 times 14. So the answer is x is equal to 7. Y is the longer leg. The longer leg is equal to A square root of 3. But note that A is equal to x. So by substitution, y is equal to x square root of 3. As a result, y is equal to 7 square root of 3. Let's do some sheet work. You can try answering the exercises, which are problems about the 45 degrees, 45 degrees, 90 degrees, and 30 degrees, 60 degrees, 90 degrees triangle. For the generalization, there are two types of special right triangle. The first one is the 45 degrees, 45 degrees, 90 degrees triangle. And the second is 30 degrees, 60 degrees, 90 degrees triangle. The 45 degrees, 45 degrees, 90 degrees triangle is isosceles, and the measure of the hypotenuse is leg times square root of 2. The measure of the hypotenuse in 30 degrees, 60 degrees, 90 degrees triangle is twice the shorter leg, while the measure of longer leg is the measure of the shorter leg times square root of 3.